today we are solving this problem, minimum number of operations to move all balls to each box. So basically what is happening is you have an box, you have n boxes, and you are given a binary string boxes of length n, where box I is 0 if ith box is empty and 1 if it contains one ball. So basically if it box I is 0, that means the ball, there is no ball, but if it is 1, that means there is one ball. So in one operation you can move one ball from a box to an adjacent box. Okay, so only one adjacent movement is possible. So let's say if you want to move a ball from 0 to second location, then you have to have the two operations, right? So we can move a ball in one time or in one operation only to the adjacent box. Okay, so what we have to do is return an answer of size n, where answer I is the minimum number of operations needed to move all the balls to the ith box. So what does it mean is, let me explain it properly. Suppose this is our box's string. Okay, so this can be like 1 1 0, right? So what we have to do is, we have to make an answer array like this. Let's say whatever is the size of boxes, same answer array size also would be there. Now see here, you guys can observe here, this is first location, right? 0. So at 0 location there is 1, so no problem, this 1 is already at 0, but there is one, this is 1, right? This is another one at location 1, right? So only one left is this one for this location. So in one operation we can move this one to here, right? So there is only one operation. So how many operations this first location will take? So in answer it would be answer 1, because only one we have to move is in one operation. Now come to this guy, this location. So other than this guy, there is only one here at index 0, so we can move it in only one operation, right? So this also can be accommodated. All the ones are traveled to the location 1 also in one operation only, because 0 we are not supposed to do that. 0 doesn't have ball. Now come to this 0, this location, right? This is second location, basically 0 1 2. Now there are two ones sitting at 0 at index 1, so all of them should be traveled to this guy. So this guy, the index 1 can travel here directly in one operation. So one operation is to move this guy. Now we have this guy also, this is also 1. So if we want to move it to 0th location, first it has to come to this location, correct? And then from here it will go to this 0 finally. So here we need two operations, right? So 1 plus 2, right? So our answer should be this. It should be like 1 1 and 3. So we have to, this is what we have to do. So if I sum up, we can say that at every cell we want to travel all other ones. Wherever these ones are sitting, we have to traverse to the any ith location. Then what is the minimum operations we needed? So for example here, this guy only one, so one operation can travel. Similarly one operation, but to make all these 1 to here, it will take 3 operations. This is what we have to do. This is one of very simple example. Okay, there could be like huge number of cases, then how to handle all those, that also would be a scenario. For example, now one technique I will tell you here, not solution but one utility that we gonna use. So for example here, till here we are using 3 operations. Now let's say there was one more 0 here. Okay, so to move all these ones, it wouldn't like 3 plus 1, no, it would be whatever is the operation at here plus whatever is the frequency of ones, because every one index every one we have to move to this location. So it's not like that if it is at let's say it is 0 1 2 and 3, so it is not like whatever is the operation at 2 plus 1, no, it would be whatever is the operation at 2 plus whatever is the frequency till here of ones. So it would be 3 plus frequency is 2. 3 is the answer at here. So 3 plus what is the frequency of ones on the left side of this guy? It is 2, right? So we will add that frequency 2. You can observe also here that there are 2 ones. So it would be every index would be increased by one time, so it would be equivalent to the total frequency of it. So that is why it would be whatever is the answer at 2 plus whatever is the frequency of ones. So this concept also we will use while we would be solving this problem. Now guys, there could be the both possibility that ones might come from left side as well as right side, and we have to move all of them because this is one of the simple example. What if it is like this, that 1 and this is 0, then we have this all, then we have this 1, then we have another one. Now see here, all these ones, when we will come to this guy 0, right, all these ones should be moved to here, right? So one operation this guy would be taking. Similarly, one operation would be taken by this guy, and 2 operation would be taken by this guy. So all of them we have to make it moved to 0. So consider from left side 1 as well as right side 1, all of them should be moved to every boxes. That is why we will get this answer array. So this is what we have to do. Now I will take one better example to make it very crystal clear. So let me draw a better example. So guys, this time I have taken this example. Let's say this is our string boxes 001011. So this is the our string in the red thing, okay, and this is our answer array that we have to accommodate. So as you guys know that the ones could be from left side as well as from right side, and we have to make the operation so that all the ones could move to every index, right? So let's say we are first of all looking for the left side one. To make you understand, I am making, let's say first we are going from left side, okay. So we will have two variables here, the number of moves, okay, number of moves and the count of ones, let's say. So here this is one variable is moves and one variable is count. Now you guys can have, initially it would be 0, moves is 0 and count is also 0, because when we are coming at the very first location there is nothing on the left side, right? So whatever is this index at answer I, what we will do is answer I, it would be like let's say answer I is equal to answer I plus moves, okay, answer I equal to answer I plus moves, whatever is the moves we have. So it would be like this, moves. Now you guys can observe here, initially let me remove it, initially the moves are 0 only, okay, so this would be 0. You can also observe that there is no left side, so there is no possibility of anything, so we have made it 0. Now we are coming to this index, right, this index which is 1, right? So what is happening here, this guy also 0 only, and left side also there is no frequency, so count is also 0, moves is also 0 here. Remember, we are going first only for the left side, so here also what it would be, answer plus moves, yeah, this is 0 only, okay. Now we are coming to this index. Till here also left side there is no count, right? So there is no possibility of any operation. So here also we will make 0 only. Okay, we have made it 0 only. But this time the count has become 1, right? Because 1 is appeared first time. Now we are coming to this guy. We are at here. Now again, whenever we have count, we will update to these moves. So far it was 0, but moves also, moves equal to moves plus count, okay. So moves equal to moves plus count, let me write it like this, okay. So as soon as some count increase, then only that moves also would be increased that many times, whatever is the frequency. So this time moves would become 1 here. So now we are coming to this guy, right, at this index 3. So this would be whatever index 3, 0 plus what is this value? This value would be now moves is 1. So now it would become 1 here, right? Now our moves is 1. Now for every count, see now every time when we are moving ahead, right, now we are coming to this index, right? So this will be answer plus moves, but moves would be moves plus count here. So when we are coming to this location, what would be the moves? Initially moves value is 1 and count is also 1. So it would become now 2, right? So what we will do here at this location, we will put it 2. So let me put it 2 here. Now we are coming to this guy, okay? And this guy is 1 here. So count would be increased by 1, right? This, because this was 1. So count would become now 2. And when we are coming to the moves equal to moves plus count, right? So move is already 2, so it would be 2 plus what is the count now? Count also 2, so 2 plus 2, so moves value, new value of moves would be 4. Okay, so answer is equal to answer plus moves, so now it would become 4, right? So this would be our left operations, that every place the left side one would be taking these many operations. Okay, now similarly we can do on this answer array, we can update it for the right side as well. Okay, so let me go for the right side as well with the same approach. Okay, here also same approach would be there. Here also we would have moves equal to moves plus count. So let me make it moves, I deleted, moves is equal to again moves equal to moves plus count. That was our formula. Now we are going from the right side, so let's come to the right side. So this time we are anchoring from right to left. Okay, so what we will do, we are at here, this guy is very first guy, so nothing on right side, right? So let me reset these values also. Initially everything would be 0, so let me go till here. Okay, everything we have met, the count also 0, the moves also 0, and this is our moves equal to moves plus count. Okay, answer I is equal to answer plus moves I, right? So now we are coming from right to left, so we are at very first guy. So what will happen here at this guy? There is no possibility on right side, so our frequency would be as it is, keep it as 4 only. Now we are coming to this guy, but before going to this guy we have to update few things, right? Our moves, so our count would become 1, right? We have made count equal to 1. At the same time, before moving to the left side, we have to make the moves also. So moves equal to moves plus count, so it would become what? It would also become 1. Now we are coming to this guy, right? Second location here. So what would be the answer here? Answer equal to answer plus moves. So what is the value here? Answer is 2 plus what is the move here? Move is equal to 1. So 2 plus 1. Okay, so now we have we have filled till here. Okay, moves is equal to 1. Now we have to see, this is 1, right? This is 1, so our count would become increased by 1. So we have increased the count by 1, and moves also would be increased by 1 by these many counts, right? So moves equal to 1 plus 2. Remember that every time when we are increasing the value, any index, it would become whatever is the count of 1, that many times it is increasing. That is why I am making it moves equal to moves plus count, because these many values, these many ones we have to move to the next location, so it would increase by count. So now new moves would become 3, right? So moves is equal to 3. Now we are coming to this guy, right? So at this guy, what would be the answer? Answer equal to answer plus moves. So answer 1 is already there, and we would be adding moves, so this would be 1 plus 3, right? So this would become 1 plus 3. Now because this guy is 0 only, so count would be unaffected, so it would be again 2 only, and our moves also would be, now moves, every time moves we would be increasing, right? So moves equal to whatever is the moves value, so it is 3, it is 3 plus whatever is the count, 3 plus 2, so move now would become 5. You guys should not be confused, because if we are moving ahead, count number of operations would be every time increased, doesn't matter if it is 0 or 1. Okay, so now we have 5 here. Now we have to fill this value here. Now we are coming to this guy. Okay, so this guy, so answer would equal to answer plus moves, right? So this is 0 already, so 0 plus moves equal to 5. So what would be here? We would have make it 5. Okay, and count is unaffected. Count is increased by 1 because this is 1, right? So what would be our count? Our count would become 3 now. And what would be our moves? Moves would be whatever is the current value, 5 plus whatever the current count. So 5 plus 3, this would become 8, right? So our moves value would become 8. Now we are coming to this guy. So this guy is what is the value here? Already 0 plus what is the answer equal to answer plus moves. So moves is 8. So 0 plus 8. Now we have to again calculate, because this guy is 0, so count would be unaffected. Count would be still 3. Now so what would be the moves? Moves would be whatever is the current value, which is 8, plus whatever is the current count, plus 3. So 8 plus 3. So 11 would be the our new value. So let me put it our new value here as 11. Now we are coming to this guy, final guy. Okay. So at final guy, what would be? Answer I equal to answer I plus moves. So moves equal to 11. So we have to add this 0 plus 11. Right? 0 plus 11. So this would be our answer here. Now you guys have seen that from left to right we went, then on the same array we updated from right to left. Okay, so this would be our effective value. It is 11, 8, 5. Just sum up. It's not a big problem, right? You can sum it. So this would be our answer array. Now the thing is, you guys might be understanding that I have used two loops, because one from left to right and one from right to left. Obviously, yeah. But this I have done just to make you understand. But we can use mathematically we can do it in single loop itself. We don't have to use two loop. Let me show you that as well, that how would we accommodate these two changes in a single loop itself. Would we tell you? So when we go to left, right, when we did the left operation, we started from I equal to 0 to n minus 1, right? This was our left side operation, and we have our moves and count, right? We can just say in left move, right? In case of, so we can move left move and L count, we can call them, right? So it was starting from 0 to n minus 1. Now when we are coming to the very first, similarly in the same loop we want to come very first of the right side. So how we can do is, we can do it easily. I equal to 0 to n minus 1 from left to right. Similarly we can do this by j equal to n minus 1 minus I, right? N minus 1 minus I. You can check it. If we put this value, this I equal to 0, so if we put n minus 1 minus I, so n minus 1 minus 0, so this will indicate this guy, the one which coming from the end side, right? So n minus 1 minus I to j is greater than 0, right? So similarly with this formula, every time if we do n minus 1 minus j, we will have a equivalent right side guy as well. So here on 0th location, then we would be here. When our I would become here, this guy n minus 1 would be giving us the second last guy. So similarly here we can have the right side, we can have the R move, we can have a variable called R move and R count, and similarly we can do that operation which we did. So now I will show you this in terms of my code, okay, which will make a clear understanding of it. So let me write down my code as well, simple code for it. So see here, I have made that L moves, L count, R moves, R count for left and right respectively. Here I am getting the length of it, and this is my answer array that we have created. Now what we are doing is, we are traversing from I equal to 0 to I less than I plus plus. So see here, answer I equal to answer of left moves. With I we are anchoring for the left side, right? So see here, I'm same thing. What I am doing is, here I am counting the L count equal to whatever is the character. If it is character is 1, then anyway we have to increase by 1, otherwise it would be 0. So L count I am moving in this way, and then I am making L moves equal to L moves plus L count, same way that way we were doing here, right? And then see here, this is for right side. So if we do j equal to n minus 1 minus I, we are getting rightly similar value, that the one anchoring at ith, it would be from nth, okay, from end first. Okay, so same distance from I, from end, and same like the start from left, and this would be from end. So now here also we are doing same thing. Answer j equal to answer j plus R moves, and this is our count, that whatever is the character at j, if it is 1, then only we are increasing by 1. And similarly R moves equal to R moves plus R count. As I told you, every time in every moves we have to increase by whatever count of ones are there, because that many moves would be definitely increased. Okay, so after doing this, what we are doing here, we are increasing for answer j at the jth location, and here we increased for the answer I, okay, from left side. So this would be effectively, when this run entire code, we would have the effective moves that are required minimum from left side ones as well as for the right side ones. So let me execute my code here. So I am executing my code. Yeah, let me try to submit it. So anyway, here we are taking the time complexity single pass. Okay, it is 61.64%. So it's a single pass time complexity. So thank you for watching this video. If you guys have any concern, please make a comment over there. Thank you.